Welcome students and to my channel and your favorite channel actually, and Pradeep sir classes has PSC. And today students I clear your concepts about AC Verma, that is from 21 to 24, and all the numericals basically are based on the pitfall repulsion problem. It may be attraction or repulsion problem and the different concepts around this. And I think most of the numericals, but basically most of the year, this type of component divisions always one or two questions, one questions, or it may be within joint or IIT. It will, you can get one question at least. So students, let's try and clear your concepts of these typical concepts, that is pitfall, repulsion or interaction problem. So all the numericals except 21, all the numericals are based on pitfall, repulsion or attraction problem. So let's start. So students, 21 questions, question number 21 is from basic numericals. Two charge particles having charge 2.0 into 10 to the power minus 8 coulomb each are joined by insulating string. So this is a insulating string, and this is insulating string. Why it is insulating? Because if we given a particular charge 2.0 into 10 to the power minus 8 coulomb, then it stays at that particular position, and if it is a conductor, then it is neutralized. So when we rub a comb with our hands, then the charge resides on the comb, and if the comb is a conductor, then charge neutralized through our hands. So it must be an insulator. So these two charges are kept by the two insulating string of 1 meter, and then that particular system is kept on the horizontal table. Find the tension. Okay, so this tension, these charges repel this one, and the distance between them is 21 is 1 meter, and show the repulsion force. It is so simple, students, because this is the tension force, then this tensional force is contributed that particular Coulombian repulsion. So 1 kappa, this is a proportionality constant, and q into q, that is q square by distance square. So kappa equal to 9 into 10 to the power 9 into 2.0 into 10 to the power minus 8 into again 2.0 into 10 to the power minus 8 divided by r square, that is 1 meter whole square, and this is 9 to the 18, 18 to the 36 into 10 to the power 9 into 10 to the power 16. So 36 into 10 to the power of 16. So this is 7 minus 7, that is 3. If we take 3.6, and then it is decreases, so it is increases minus 6 Newton. So 3.6 into 10 to minus 6 Newton, and you can check your answer. 20, question number 21, 3.6 into 10 to minus 6 Newton. Okay, it is correct. And so the answer is it is from the base numericals. What is Coulomb's law? You know that the force is directly proportional to the product of the charges and inversely proportional to the square of the distance between them, and if we equal this one, then a proportionality constant kappa q1 q2 by r square is given, and this particular constant is depends upon the system used and that particular medium where the charge is kept. So students, 21 is completed, and next go to the 22. So students, the next one is 21, and it is given to identical balls each having a charge of 2.00 into 10 to the minus 7 coulomb and a mass of 100 gram. 100 gram are suspended from a common point by two insulating strings, and each 50 centimeter long. So question number 22, and and this is a common point. And first of all, this is you think that this type of numericals is given in 25 number numericals, so it is not a equilibrium position. If equilibrium reach, then it is fixed, but this is not equilibrium, so these two charged particles repel each other along a particular direction. So we know that this repulsion force is always along the line joining the charged particles. So along that particular direction, Coulombian electrostatic force, electrostatic repulsion is acts along this direction, and there is a mass. Mass is also given, that is mass is 100 gram, and this is insulating string, this is 50 centimeter, and this is fish, and this separation is given 5 centimeter, this separation between the charges. And Q is also given, that is 2.00 into 10 to the power minus 7 coulomb. So this is the figure. First of all, figure out the problems and think about it. So two identical balls, identical in each, having a charge of this one, okay, and a mass of 100, as suspended from a common point by two insulating strings, and each of 50 centimeter long. The balls are held at a separation of 5 centimeter apart and then released. And students, first of all, find the electric force on one of the charged balls. So first question, the answer is, first of all, the answer is, what is the repulsion force? What is the repulsion force at that moment? So when the separation is 5 centimeter, then what is the repulsion force? So it is too simple, and we can calculate F equal to 1 by 4 pi epsilon naught into q, that is q square by r square, since the two charged particles given here are identical. So this is 9 into 10 to the power 9 into q square, that is 2.00 into 10 to the power minus 7. Again, this is similar identical charge, so this is 10 to the minus 7, and divided by r square, that is 5 centimeters, so 5 by 100 whole square. So this Newton force acts at that moment, and this is value we can calculate. 9 2 ja 18, 18 2 ja 36, so 36 into 10 to the power 9 or 7 minus 14 divided by 5 5 ja 25 into 10 to the power of 2 and this will goes to the numerator position. So 100 that is 4. So 9 1 10 or 13 minus 14 10, so 36 by 25 divided by 10. So these we get 36 so we get 36 into 36 divided by 25 divided 10, 0.11. so the answer is 0.144 Newton. This Newton force acts. So it is, I think it is the part one is so simple, and the second part, so second part is the electric force on one charge ball and the component of the resultant force on it along and perpendicular to the string, and the tension in the string. So second option is the component of the resultant force along and perpendicular to the string, and the tension in the string, the acceleration of one of the balls. Okay, so when it this and this one is repel, then it goes along this direction. If we draw a tangent, then it goes along this direction. So this will be the perpendicular with this one, and and along that particular direction. So you have to calculate these two component, and if we can calculate if this is theta, if this is theta, then this angle is also theta. This angle is also theta because this is corresponding angle, and this angle is, think, 90 degree minus theta. Yes, and this angle is also 90 degree minus theta, and this angle is theta. So first of all, students, think about the different angles. So when these two balls repel, then it goes along this direction, and this is along this direction, similar to that one, and takes and stable at a particular equilibrium position. So this is FC cos theta, this is FC cos theta, and this is FC sin theta, this is mg, and this is, since this is mg, and so this is mg, so this is mg plus mg cos theta, and this is mg, since this is mg cos theta, and this is mg sin theta, or mg cos 90 degree minus theta. So simple. So FC, we know that FC is 0.144. So along this direction, so FC acts along that particular and particular direction, but this force, this tension force, if this is tension force, then it is also theta, alternate angle. This angle is equal to this alternate angle, so this component will be T cos theta, and this one, and this one is T sin theta, along that particular direction. And so, but the ball moves along this direction, so that particular force, and this is in equilibrium conditions, and so first of all we have to calculate the component of FC along that particular direction or along these directions. Along this direction, so cos theta equal to, if this is theta, then cos theta equal to base, so this one base by hypotenuse. Since this is theta, so that particular is 2.5 centimeter, and this will be so cos theta equal to base by hypotenuse. So base is root under 50 square minus 2.5 whole square, 50 square minus 2.5 whole square. This is base, hypotenuse square equal to perpendicular base square, so this square will be this square minus this square, divided by 50, this is cos theta, and centimeter, so cancel each other, so unit you have not changed that particular unit, and so cos theta, and then calculate FC cos theta. So FC cos theta, so this is FC means 0.144 into cos theta means 50 square minus 2.5 whole square divided by 50. So 50 square, 50 whole square minus 2.5 whole square equal to root over of answer, equal to root over of answer equal to divided by answer divided by 50. So this is 0.998, 998. So this is 0.999 approx. So these into 0.144. This is 0.143. This is 0.143. This is 0.1438 Newton acts along the perpendicular to the string, along perpendicular to the string, and along the string it is 0, and along the string it is 0. Along the string it is 0. So this will be another answer. So again read the numericals. The electric field on the charged bodies, so it is completed, and the components of the resultant force on it along and perpendicular to the string, so this is completed, and the tension in the string. So the tension is Fc sin theta plus mg cos theta. So the tension is since this tension balances this one, Fc sin theta plus mg cos theta, so tension is equal to that particular value. So tension equal to Fc sin theta plus mg cos theta, So Fc means 0.144 into sin theta. Sin theta means perpendicular 2.5 perpendicular by hypotenuse. There is sin theta perpendicular hypotenuse plus mg. M means 100 divided by 1000 because it is in gram, into 9.8 into cos theta. So cos theta equal to 0.999. This cancel this one, so 0.9 into this, and calculating 0.144 into 2.5 divided by 50 equal to plus answer plus 9.8 into 0.999 divided 10 equal to 0.986. so this is equal to 0.986 Newton. So this is the value of tension. This is the value of tension. First of all check it. That is 22 0.095 away from the other charge. First of all 0. This answer is 0. And the second one along the direction 0.095. This is Fc cos theta 0.143 0.986. so this answer is tension. It is okay. So this is the tension, and 0.095 Newton, 0.095 Fc cos theta. Sorry, this is Fc cos theta. Sorry, this answer is correct. This answer is correct, and this one is also correct because 0.44. Yes, 22 20 0.44. This answer is correct, and this one is also correct, and this one is also correct, but this one I mistake something. Check it. So yes, this is Fc cos theta, but the resultant force along Fc cos theta and you have to multiply that one, mg sin theta. Then you get along that particular direction. So this is okay. And also you have to calculate mg sin theta. So mg sin theta, for mg, m means 100 divided by 1000 into g, that is 9.1, and sin theta, this is 0. 2.5, 2.5, that is sin theta. Sin theta means perpendicular by hypotenuse, so 2.5 divided by 50, and this is centimeter, this is also centimeter, so you have not take into account the consideration of that particular input. So this is 9.8 into 2.5, so 9.8. So students, this is 9.8 into 2.5 divided by 10 divided by 50. Yes, it is 0.049. 9.8 into 2.5, yes, into divided by 10 divided by 50. So this is 0.049. So this is 0.049. Okay, and then you have to subtract this one, because that particular balls moves along this direction, so the resultant force you get this minus this one. So fc cos theta means 0.04, so fc cos theta minus of mg sin theta, fc cos theta minus, so 0.1438 minus 0.049, and this gives this one, and if we subtract 0.1438 minus 0.049, this gives 0.0948. so this is 0.0948948, or approximate, we can say that this is 95. So that particular force along this direction, 0.095. so this is 0. It will be 0.095. This amount of force acts along this direction, net force. So this is the net force acts along this direction. So the next answer is 0.95 meter by second square perpendicular. So this is the acceleration. So then you have to calculate acceleration. So acceleration equal to force by mass. So the force is 0.095 by mass. Mass means 100 gram divided by 1000. 100 divided by 1000, so this is cancelled, this one, so 0.95, because 0.095 meter by second square. So this is the final answer. And if you take into account the particular values into suppose 10 g, if you take the acceleration due to gravity as 10, then the answer is somehow it will be actually the answer is right, but it doesn't match with that particular answer. And so I think students, you have to clear that once. So all the answers is correct. So this is 0.095 Newton, this is 0.095 Newton. Okay, so first answer. So the first answer is 0.144. I repeat again, this numericals is too much critical because of you have not that particular concept. But if you clear your concepts of resolution of vectors from class 10 11th level vectors, then it is too much easy. So first of all, students, take into account that particular ball is, this particular ball repel these along these directions, but it goes along the tangent. This is the tangent, along this tangent direction, because this ripple along this particular direction. So this is FC, then it is FC cos theta, and it is FC sin theta. First of all, resolve this force and this force. There are two forces. So this is mg sin theta and mg cos theta, FC cos theta, FC sin theta. And then angle, this is theta, this is also theta. Since this is theta, so this is vertically opposite angle, so this is 90 minus theta, this is also 90 minus, and this is theta. So first of all, divided step 1, divided angle, step 1, divide all the angles, and the second step, divide forces, resolute all the forces, First of all, divide all the angles and then resolute all the forces if required. Then it is too simple. Then along this direction, FC cos theta minus mg sin theta, because this repel this one and this goes along this particular directions. And if you calculate tension, then this plus this equal to tension, equilibrium position. And these force acts along this one is and that particular forces. So this tensional force equal to this one. So along that particular string, the net force is 0. So this is the vital point. So the net force along the string is 0 because the string moves in a particular direction. That is, if we draw a tangent around this line, then ball goes along this direction. So along this particular, there is no component of force. It is in equilibrium. So this is the basic point. And they do the numericals. And all the calculations to be calculated at the instant of time, because it is also variable. At a particular time, the balls comes into rest. So all the answers, all the considerations, it is given the acceleration of the ball, and assume the answers has to be obtained only for the instant and just after the release. So when 22 is cleared, then I think 21 is so simple, and 23. So next, so students, the next one is 23, and the 23 is two identical pith ball, and all the numericals actually 22, 23, 24, 25, and very important numericals, because it is all the problems are related with pith ball problem. Mainly students first of discuss with the what are the different types of pith ball problem. So this is one kind of problem when you suspended two balls, then if that particular ball is in same nature, then they repel each other, it will be a problem. And this is in equilibrium condition, but if the equilibrium doesn't attain, then that particular ball moves along this particular direction. So this is question number 22 I just completed, and this will be the 23. 24 numericals is this pattern, the equilibrium. 25 is also this pattern. No. 23 is different. 23 is different, like that particular concepts. And if this is different in nature, then repel these, attract this one, and if they are different, then repel this one. So there are two different structure. It will be this one, and again it will be that particular ones. So these all the all numericals are related with some pith ball repulsion. And so 23, question number 23, two identical pith balls are charged by rubbing against each other. So this is the main concept. Two pith ball charged by rubbing. means, and this is if the charge is actually follows the conservation principle. So if one ball is q coulomb, then the another ball is obviously minus q coulomb charge, because charge the electrons transfer from one body to another. So you know that first from the first line that the ball attract each other, because this is conservation principle acts along with the balls. They suspended from a horizontal rod through two strings of 20 centimeter each. So this is that particular type, and this is a horizontal rod, and this is 5 centimeter separation, and the string is 20 centimeter, and this is the string, not this one, because these and these attract each other. So this is 20 centimeter, and the concept is wrong when you take that particular value is 20. This is not 20 centimeter, this is not, because it attracts this one and that particular length. This is the hypotenuse is 20 centimeter. Hypotenuse is 20 centimeter. If you take perpendicular as 20 centimeter, then the answer is wrong. So this is 20 centimeter, and these two balls attract each other, and then the separation is 3 centimeter. And first of all, the separation is 5 centimeter. So that particular value is 1 centimeter, and this is also 1 centimeter. So this is the first concept. Okay, the next one is the 20 centimeter each, and the separation between the suspension points are 5 centimeter. In equilibrium, the separation between these is 3 centimeter. Find the mass of each ball and the tension in the strings, and charge is given. Okay, so first of all, students, their tension acts along this direction. So this is theta, so this is t cos theta, and theta related angle is always t cos theta, and this is t sin theta. So along that particular direction, t sin theta acts t sin theta, and this is t cos theta. So t sin theta is equal to the attractional force, because these and these ball attract each other. So this is the attractional force acts along this direction. So this is t sin theta equal to k q1 q2. All the charges are same by separation, that is 3 centimeters. So 3 by 100, because this is in centimeters. So this is equation 2, and t cos theta equal to mg, because t cos theta along these directions, and this is mg. So t cos theta equal to mg. So t cos theta equal to this one, t sin theta equal to this one. Therefore, if we divided this by this, then cot theta equal to mg by this. Cot theta by dividing 1 divided 2. So students, if we calculate cot theta, then we can get the mass of the ball. So what is cos theta? So this is theta, so this is theta, then this is perpendicular, this is hypotenuse. So you can get sin theta easily 1 by 20. So sin theta equal to 1 by 20. Then cosec theta is 20, and cosec square equal to 1 plus cot square, we know that. So cot square equal to 400 minus 1, or cot theta equal to 300, or cot theta equal to root over of this. So this is cot square theta, and then cot theta equal to root over 399 root under 399. So you can place root over of this one, and then multiply this one, and get mg, m, and we get g taken as 9.8. so this is this meter, and this m is sorry there's m equal to this one. So 10 to the power minus 3 means this kg, and if we convert this is, that is 8.2 gram by multiplying 10 to the power 3. So this is gram. So the answer is so simple. The next one is 24. 24 is so simple. Actually these numericals is comparatively tough between 22, 23, 24 and 25, and all the problems are related with pith ball problems. So two small spheres, each having a mass 20 gram, are suspended from a common point by two insulating strings of length 40 centimeter each. Two spheres, each having a mass of this one, and suspended from a common point by two insulating strings 40 centimeter. The length of the string. So the length of the string is 40 centimeter, and they repel each other since the charge is same. So this is t, then this is t cos theta, and this is t sin theta, because theta, this is theta, so this is the alternate angle. So this is cos theta and this is sin theta, and the repulsion force acts along this particular directions. And so this is k kappa, k means kappa, q1 q2, that is q square by the separation of distance by r square, and it is given, it is 4 centimeter. So t sin theta is equal to kappa q square by 4 by 100 square, and t cos theta equal to mg. And all the people problems, you can get two equations, then divide it, and this is the basic rule. So tan theta equal to this one, or tan theta you can calculate here from sin theta equal to perpendicular by hypotenuse, and then cot theta you can calculate cot theta. And so since sin theta equal to 1 by 20, then cot theta it must be this one, because sin theta equal to 1 by 20 and cot theta equal to this one. This is if 23 is calculated, then you can take this one as 1 by 20. Since this is 120, then cot theta will be this one. So if you put here with the value of this one, 1 by tan theta, that is cot theta, 1 by cot theta, this is tan theta, so 1 by root over of this one, or q square equal to this one, or q equal to this one. Okay, so pause the video and copy this one. Okay, so 21, and you think that so do the numericals from 25 to 31 first, and then 21 to 24. Why? Because all the numericals are related with people problems, and this is more conceptual problem comparing the other numericals. So if when your concept is clear, then I think try more and more conceptual problems, that will be better. So thank you students, and if you think that this is a more conceptual and more technical channel, then subscribe and continue your study. Thank you.